Hello everyone, I am Brandon Ordoñez from ECE41 and today I will be performing an activity for our Internet of Things laboratory which is entitled Simple Application Using Raspberry Pi with an Ultrasonic Distance Sensor. Hello everyone, so now let us begin with our activity. So for the instruction, kindly drop here your blog that shows your created simple application of Raspberry Pi using GPIO's input and output ports. So first, a little background about the ultrasonic distance sensor that I will be using for this application. As the name indicates, ultrasonic sensors measure distance by using ultrasonic waves. The sensor head emits an ultrasonic wave and receives the wave reflected back from the target. Ultrasonic sensors measure the distance to the target by measuring the time between the emission and reception. In air, sound travels at a speed of 343 meters per second. An ultrasonic distance sensor sends out pulses of ultrasonic sounds or ultrasounds which are inaudible to humans and detect the echo that is sent back when the sound bounces off a nearby object. It then uses the speed of sound to calculate the distance from the object. So for this experiment, we would not necessarily compute the distance of an object to be detected by the sensor, but we will be detecting the presence of an object within the range of the sensor. If an object is detected by the sensor, it is expected that the LED placed in the circuit will light up. While no object is detected, the LED will remain unlit. So figure 1 shows the ultrasonic distance sensor that we will be using for this experiment. So next, for the circuit assembly, I have prepared 3 photos that will show the circuit built. So this is the proposed circuit assembly using fritzing. This is the schematic diagram. And this is our actual circuit assembly. So let's head to fritzing for us to know the circuit to be built. So first, the VCC port of our ultrasonic sensor is connected to the 5 volts VCC of our Raspberry Pi 4. Next, the trigger port of our sensor is connected to GPIO4. Next, for the echo, it is connected at GPIO7 with two 220 ohms resistor connected in parallel by the echo port of our sensor, which is then connected to the ground, and the ground port of our sensor is connected to the ground port or to the ground terminal of our breadboard. Next, at GPIO27, I have connected an LED which would be our output when motion or an object is detected by our sensor. It is then connected to the ground after placing a 220 ohms resistor. Lastly, the ground port of our Raspberry Pi 4 is connected to the ground terminal of our breadboard. So this is the schematic diagram. It shows the same thing, the VCC connected to the 5 volt terminal, the trigger connected to GPIO4, the echo connected in parallel with two 220 ohms resistor, which is then connected to GPIO17. Next, part of it is connected to the ground. Next, the ground port of our sensor is connected to the ground terminal of our breadboard, which is then connected to the ground port of our Raspberry Pi 4. Next, the LED is connected to GPIO27. And after the 220 ohms resistor, it is then connected to the ground. So next, this is our circuit assembly, which will be shown later. Next, for the Python code, we will then open up our recorded simulation from our Raspberry Pi 4 desktop. So this is our recorded simulation. So now I will open the file I've created from Tony Python using our Raspberry Pi 4. So this is the code used for this experiment. So first, from GPIO 0, import distance sensor, and from GPIO 0, import LED. These are the libraries to be used for this experiment. So first, I have created two functions to be called out later. First, for the hello, for the first function, I have named it hello. When this function is called, a message would appear at our Tony Python that says in range, and also the LED would turn on. Afterwards, I've created another function called by. Um, when this function is called, out of range message would appear and our LED would turn off. So next, the light. So first, I have created a variable called light, which is our LED connected at pin 27. Next, for the ultrasonic, I have named the variable named ultrasonic. So for the distance sensor, the echo is connected at pin GPIO 17 and the trigger is connected at GPIO 4 as I have shown earlier. And the threshold distance that I have set for this experiment is 0.2. So ultrasonic dot when in range, so when an object is detected within the range or the threshold distance of our sensor, the hello function would be called, which says that a message would appear saying in range and the LED would turn on connected at pin 27. On the other hand, ultrasonic dot when out of range, when no object is detected by the sensor or the object used is out of range from the sensor's range, the by function would be called that says out of range and the LED would turn off. So now I will click run for us to see the experiment and for it to be applied to our circuit assembly.
So after showing you the code of our experiment and the circuit assembly using fritzing, let us try to see if the circuit would perform its expected results. So first, I'll place my hand at the 1 centimeter mark from our sensor. There, as you could see, the LED lights up. And if I remove my hand, the LED turns off. Next, at the 2 centimeter mark, there, the LED lights up. And if I remove my hand, the LED turns off. Now let's try at the 3 centimeter mark. There. Next, at the 4th, 5th, 6th, 7th, 8th, 9, 10, 11, 12, 13, 14, 15. So after that, I will try to place my hand outside our ruler. So here. So we could see the LED does not light up, meaning that the object or my hand is now out of range from the sensor. So as we could see from our monitor, there, whenever that the sensor detects, it says in range, and whenever I will remove my hand or whenever the object used to be detected by the sensor is outside of its range, it shows out of range. So now let us try again to see. We could use any object too. So example, this card. there. So that is it for our simple application using our Raspberry Pi.